Hi, I'm Alan Percy, CMO at Telco Bridges, and welcome to the Telco Bridges ProSBC Tech Trained Educational Video Series. This multi-part video is a collection of individual modules that together will give you the knowledge and tools to install, configure, and diagnose complex FreeSBC and ProSBC deployments. Presented by Luc Morissette, our Director of Customer Service, the material was recorded over 2 days in our corporate office in Montreal. The video includes a live classroom setting, includes many of the participant questions and interactions, so welcome to the class. We've broken the recordings into 13 smaller modules, allowing you to view them in smaller portions, giving you a chance to try some of the actions discussed in the video before moving on. The modules are ordered by a sequence number, starting with 104 and skipping the occasional number, kind of like house numbers on a street. As you progress through the materials, it's a good idea to jot down the module number as you complete them. Also, a link to the slides can be found in the text down below. You may find looking at those slides while viewing the video will help. So let's get started with Module 104, giving an overview of Telco Bridges and the SBC product portfolio capabilities, its use cases, supported hardware platforms, and installation processes.
So let's go. Here is an overview of the SBCs. I tried to take all the functionalities to present them, okay, of the SBC. So I'm going to touch about all of these. Network access point. I think most of you already worked with the SBC, so then they know what is a NAP here. The SIP configuration, call and mission control, the NATing, registration, SIP-I. I think you guys want to do SIP-I as well, or no? No, not yet. But if you connect with SFR, yes. They may want to have SIP-I. Okay. So I put it there. Fraud calls, lawful interception, some stuff about monitoring, remote configuration of the SBC. So these are all things we can do with the SBC. Transcoding, playing and recording, and also media bypass. I don't talk about a lot about media bypass, but if someone is interested, we can talk about that later. Some of the performance criteria that we want to show here. Just a bit of information on the installation. The installation is documented on the wiki, so you just have to follow the procedure. I think it's pretty clear, pretty useful, but here I want to point out just a few more things. Okay. So things that, well, let me just go back just a little bit. We had those media gateways, right, which we're doing TDM to IP, so we had all the IP functionality in the system. And more and more, well, this SBC requests were coming in, and it was a bit difficult to do that on our gateways. So we decided to take out all of the SIP modules and add a SBC module. Okay? So this SBC module is really a software application, but a very low-level software application, right? So it runs. It attaches right down to the Ethernet devices to be able to have packet rate information. Right? So we capture all the data so we can analyze it and choose what to do with it right from this when we receive the packets. So one of the things it does is it hides the incoming IP. All right? So you can hide everything that comes out from the external to the internal. Right, so the internal systems here don't see the IPs outside or opposite. Right? We protect against denial of service attacks. So this is one external device that tries to hack into our system. We protect against distributed denial of service. There's different rules to protect against these types of attacks. Invalid calls, well, it will be dropped by the system. Right? So maybe it's going to find its way through, but it's going to be dropped just a bit later in the system. Okay, if the calling format, well, this is done at different places, either black and white listing, you can have a routing table, right? So you can verify all of these information. Registrations. For registration, we need to open up a little bit more the interface to allow receiving registers. However, we can block at some point some of those registrations. We have either rules you can add to the system, or if there's too many rates of registration, we can block that as well. We can also control the call rate or the number of calls that come in the system for particular networks. So you can choose and configure all of this. So this is all included into the SBC as a base function. In the network access points, well, you have information about your interface, and you have information about the remote network you're trying to reach. Okay? So in your local interface here, you can have one IP or an IP list, okay? IP range list that you can receive for those networks. These are attached to specific network interfaces. And then at the remote, we have the IP of the remote and the port. Okay? So this is one way to filter the calls that are coming in. So you can put a range here of networks. But the remote here has to be just one. Right? So when we send calls out, it has to be just one. Okay? Geolocation. You mean from this side?
Yeah, if you can block by...
Geolocation, no. No. I don't know what would that imply.
The IP filtering.
Geofiltering, so basically only allow IPs that originate North America, whatever the case is.
You need to define all the lists, so the answer is no.
So you can't use services that are already there. Okay.
But we accept enhancements requests. I have my list, and we have to go through every time and reorganize it.
So it's like an IP filtering, but I think there are services that will tell you, okay, this is from...
Yes,
China.
yes. So maybe you need to poll outside and get information about, yeah. Okay, so we can talk about that for sure. You can have different protocols. Right now we support 3. I think it's all that we need. UDP is the standard mode and on port 5060, of course. Then we have TCP connections. So some of them, like the Skype for Business was using TCP, Avaya, PBX were using TCP. So we support that. It doesn't add anything really on SIP to use TCP because SIP has its own retransmission mechanism. So it's not very interesting, but some of them it's mandatory. Some of the systems it's mandatory to support TCP. And then you have TLS, which is new with our version 3.1. And then you need to have certificates, and you need to exchange certificates between both ends, and then your SIP communication will be encrypted. So much more difficult to analyze. And you can add with this SRTP to encrypt also the data coming out, okay? The media. The default port for SIP TLS is 5061, okay? So that's what people are using usually. Then, however, you can use other ports like 5070, 5080, but you need to specify your own ports and remote ports, where you want to receive the data and where you want to send it. Anything else that doesn't come into the configured ports will be dropped. You can have also FQDN here. We've made it a little bit better in 3.1, so you can configure a specific DNS for the SIP interfaces, and then you can receive data here, or you can send data also to a FQDN. Okay. Call admission control, well, stuff that we can do here is for each of these networks, we can set a maximum number of incoming calls, maximum number of outgoing calls. You can set a maximum of incoming plus outgoing calls. You can set a call rate. All right, so I know you're using that, so you don't want to send more than a specific amount of calls to a specific destination. So, or incoming, of course, so we have both ways, okay, call rates. These are all things that are configurable in the interfaces, in the web interface. Network address translation, we can do either local or remote network address translation. So if the phones are behind a net or if we are behind a net, we can do both of them. Now, ideally the SBC would be directly on the public network because it already has the protection and everything, but in some, let's say some smaller installations, they need to put it behind a firewall because they maybe have only one public IP, so it's a little bit limitative. But we can configure both, and I will show you this configuration later and how it works. Okay. SIP registration, well, it's actually SIP registration forwarding, right? So we don't have a registrar inside our SBC, but we will forward all the registration requests to registrars that you already have or you need to insert in your network. So then we can receive a register requests and they will be sent to the registrars as decided by the configuration in the SBC. You can configure, well here I put 2, but you can configure multiple registrar for fallback. But it's really sent always to the same one, and then if it fails, it will be sent to the standby one. Okay? Yes?
What if you have multiple tenant systems behind the SBC? Meaning, you know, so I have multi-tenant systems that I run, and then each one of those multi-tenant systems can have many different customers on it. I'm not putting the SBC, I'd have to set, right now I don't, it's one of the things I want to use the SBC for. Right now I'm just going to the firewall straight to the multi-tenant. How would I set up the SBC to then go, okay, this guy's registering, I need it to register to this multi-tenant, this guy's registering, I need it to register to a different one.
So what you have is one registrar for one domain, right? And another registrar for another domain? Is that what you...
So right now what I do is I use just regular A records all off the same FQDN.
Okay, so when you receive here you receive a call for a specific domain?
Hosted 1.fusionnetworks.net,
Yeah.
2.fusionnetworks.net, hosted 3.fusionnetworks.net would be how it would come in currently.
Yeah, and then this is translated to a different registrar or a...
So what happens so it's an A record, so it's translated on the firewall down to a specific host.
Right.
Or a specific registrar that then handles the...
Okay, so what we can do here is, well, if it's the same registrar that handles the different records, then we can do just this way. But you can have another set of registrar for another, well, it's another domain, so I don't know if, yeah, we need to verify exactly how to configure that. Maybe we can check that later. But we can have different domains, different registrars for different domains.
So if you have different domains, you can forward them to
Yeah.
different registers.
Yeah, exactly.
You
Okay.
can route by incoming domain. So
You can route by the incoming domain. Yes.
So the
Okay.
set can have multiple FQDNs in it?
We can have only one FQDN, but for each of these FQDN, we can assign a registrar. Yeah. Okay. So So this is of interest to you. I have other slides on that later, so we'll make sure we understand. If we don't, we'll figure it out. The SIP-I information. So the SBC can do SIP to SIP-I. This is, let's say, a bit particular. Probably not all the SBC do this. I think the reason we do this is because we come from a SS7 background and we already had implemented SIP-I. So in the SIP, you have the SIP SDP, which is the codecs that you get usually, and then you have another SDP body, which is eyes up information. All right, so some of the carriers use this. In France, I know they use this. And this for us is only a configuration. You just say, yes, I want to have SIP-I, and then we'll or add these messages, these elements inside the SIP message. Okay. So these are the use cases. When we start with new customers, we like to start with a template which will give us an idea of what we're trying to do. Is it more registration, SIP registration, or it's just a interconnect platform to a CPaaS or a Skype for business interconnection and stuff like that. So if we have an idea here on what we want to do, this one is, yeah, so this one is stir shaken. So this has been popular recently. So we work with Transnexus for this one, and we do redirect to a external server to verify if the call is accepted or not, right, for fraudulent calls here. Stuff with SRS. I don't know why it's ProSBC here. I don't remember why we used ProSBC. Because, for example, TLS requires ProSBC, but I don't remember why we put it for ProSBC for asterisk. But these are use cases, and hopefully we'll add more as time goes on. So this is the fraudulent call configuration. What we have is an incoming SIP call, and what the SBC does, you can put some rules, but let's say the basic rule is verify all calls. Right? So we can, for each of the calls that come in, send it out to a external server. Well, this is a cloud instance that ClearIP is using, which is a company called Transnexus. And we send to the call to this ClearIP, and then they return us a reason cause. It's a SIP call that is being sent to the lawful enforcement agency, and you have two calls that are made, one for each of the directions. So the incoming here and the incoming here, which is sent to the lawful enforcement agency, and then they can listen to it live. They can record the data, and here you can put a long list of targets in the system. Okay. For monitoring, the preferred way is SNMP. So regular, well, SNMP or the web portal, right? So when you're working with the system, a good way to check the status is just access the web portal, look at the status, and you will see from the web client all the information from the SBC that is displayed in a readable format. So you saw that before.
Can I display active calls, concurrent calls?
How many? Or
Can I display active calls?
display from the web portal, you have the list.
Through SNMP?
Through SNMP, no.
Okay.
No. You can look at it with the call trace,
Okay.
but SNMP you don't have all the...
So it's just basically server status, load, stuff like that?
Yes, load, you can see number of calls on the NAPs, number of calls in total,
Okay.
Call rate for NAPs, ASR, all these things. Just the number of calls would be tricky because this system is aimed for 60,000 concurrent calls, so it would be a bit tough to get that with SNMP live, right? So I think that's the reason we didn't go that way.
Could the SNMP allow you to gather, maybe that's the same question. I'm thinking about concurrent calls by NAP.
By NAP, you know how many calls incoming by NAP, outgoing by NAP, the call rate, incoming call rate,
Via SNMP.
via SNMP. Yes. Okay.
That might work.
Sure. No. You can do a lot here.
You've already developed,
What's this?
This,
Oh, it's integrated into your system. Okay. So what do you have in this?
all full call trace by NAP.
By NAP, number of calls by NAP. Yeah. So what element management system are you using?
It's Grafana.
Eh?
Grafana.
Somebody knows that? I don't know.
Do you guys publish that list of voids so we can put that in?
They would like to get it.
what is your core? Are you using Zabbix or Nagios and you're tying Grafana into that?
Telegraph.
Okay.
And Prometheus.
SNMP get on
Okay, so you're doing GETs and stuff like that, and then graphing
to-
via Grafana.
Yes.
Okay.
Yes.
All right.
Everybody get that?
Void so we can put that into whatever we want, whatever system we're using.
Well, we'll have time to talk together later. Definitely, if we can work together making this, that's great. So SNMP gets, right, to get all the information. So you can query all the elements or only the ones you want. We have some traps also. There's maybe not so many things we will send traps on, but if a network interface goes down or stuff like that, it will send a trap, okay? Monitoring, we also have call detail records, which I will talk about later. What is that? But we can get a detail of all the calls that went through the system, okay? We can do a remote configuration. Unfortunately, there's just a few customers who have done this, but it's available. You can use the default mode is to use the browser, so you go and click here and click there, and you can enter the information. That's fine if you have a few systems to configure, but if you have many systems to configure, we have the option of using a RESTful API. So you can use pre-configured files, JSON files that you can upload into the system, and this will configure network access points, the routing you want, the network interfaces. So you can just dump it in there and it will automatically configure. You can activate the configuration with those APIs here. It can be handled here because one of the reasons I put it like this is because we don't support SNMP set. Right, so you cannot do SNMP set, but you can use the RESTful API, which I think is much better anyway to do that. The other way to do configuration is everything that is configured in the system is stored in a configuration database. So you can do a backup of this database and then reload it on the same system later or on another system. It's useful if you have like a bare metal server which goes dead and you don't have 1+1 or stuff like that, then you may want to restore the database on another system.
Is the database license key dependent?
The database is not license key dependent.
So you could load it on another system with a different license key?
Yeah, absolutely. Absolutely. I have a list later of what is included in the database and what is not. License is not. Okay.
Can you manage, is there anything you cannot manage with the rest of
well, yes, anything, I would say anything that is not in the configuration database cannot be handled by the RESTful API. So the license, Yeah, we need to verify everything that is not not handled with the RESTful API. But everything that is in the configuration database for sure is handled by the RESTful API. Anything that is not in the DB, we need to verify.
Okay, so I'm looking to do the route set configuration.
Yeah.
The ID maps.
Yep. Yep.
Database API call. That can be done?
That can be done. The only thing we have to verify is the size of the file, right? Because I never tested loading a very large file, so I don't know how many entries you have in your digit map.
30,000 maybe?
30,000? Okay, we will need to verify if we can load it. If not, there's probably another way to do it remotely. But you can, once it's uploaded, you can activate the configuration remotely, right? So let's verify that. 30,000 entries. We tested with the route set, we tested up to 5 million entries. So, but not with the RESTful API. The transcoding, that is an option on the system. For now, it has to be a hardware device. Right? So what we did here is we used our media gateways that we were using before, and we integrated it into the SBC so that any call that need to be transcoded will be sent to the media gateway and back out. Okay, so that can be one type of RTP traffic, and this one can be another type. If it doesn't need to be transcoded, then it's going to go directly from ingoing to outgoing call. I don't know if you noticed on the bottom here, I tried to put some links in the wiki. We call it the wiki, docs.techcobridges.com, and you get everything there. We try to keep it up to date. If something is not up to date, you tell us, and we can fix it. It's updated by the engineering team and by the support team, and even the marketing team sometimes go and change stuff here. The latest information is there. So if it's not right, then we have to fix it.
So it doesn't do any in the box.
Right now it doesn't do. We have that on our roadmap, but there's so many things that we need to do that this is always being pushed back a little bit because we do have a solution which maybe doesn't work in all, like with the cloud system, it's not so efficient. With bare metal, if you have your own installation, then it's fine, right? You just put it here, plug 2-3 cables, and you're set, right? It's fairly easy to configure in a system. Okay.
Is there a way to force the SBC, to tell the SBC to force the call to a certain codec when it's initiated?
Yes. Unfortunately, I ran out of time to do a nice presentation on this because when I was talking with the guys in R&D, they're testing all kinds of scenarios, and I went, oh there's like too many scenarios. I was not able to make something out of it. However, you can do pretty much anything, right? Force a codec, allow all the codecs. With transcoding, you can do even more options. So definitely you can do that. There's 4 or 5 options in the profiles to configure how you want it to work. Okay. If you have the transcoding device, you can do also play. The reason now it's done with the transcoding device is also because calls that come in could be any type of vocoder. So your files that you have stored here can be all the same format.
Or someone forgot his tablet in the conference room.
So the files here are all the same, and then you can play files. So there's different ways to play files. One is forced to play a ringback tone. Okay, so sometimes some of these networks, they don't support ringback tone, and you want the SBC to do the ringback tone, so that's possible. It's going to take the file and play out to the incoming call file. But you can also, in the routing script, choose when you want to play a file. So you can play it, let's say, before connecting. You can play it after disconnecting and stuff like that. So you can add some intelligence to the system. But right now it requires the transcoding device to do that. You can also record. The recordings will be stored on the SBC as WAV files, right? And then here you can choose to record. There's two ways. One is the web interface. Mostly for troubleshooting, you can choose different type of calls and it's going to record. Or you can, again, in the routing scripts, configure the thing so that it can record data, different conditions, right? If you have different. The redundancy, okay. There's a lot of things in the redundancy in the system. I will talk about this in the when we go in the SBC detailed low-level presentation. Mostly the secondary SBC, if you have a ProSBC, you can always add a standby or secondary SBC to the system. All right. It is you still need to have another system, you need to have another license key, but this license key allows you to attach it to a primary SBC. The only thing you need to have really is two control networks to allow exchange of information between the two servers. The way it works is really the primary will have everything. It will have the traffic, it will have all the routing rules, the call detail records, everything will be managed from the primary SBC. If it goes down for any reason, completely go down, the other one will take over inside of a few seconds, recover everything and start handling the traffic on the secondary SBC. Right? Right now, the SIP calls are lost. Right? So if you drop the primary, go to the secondary, the SIP calls are dropped. We started development on what we call internally the SIP HA, which allows to keep the calls when it falls over. However, because of other projects that came in, we had to postpone that a little bit. It's planned for next year. So we still plan to finish the work on the SIP HA. But this part of fallback still works today. Okay, it's going to take over inside of a few seconds. It can switch over on any of the application failures. So if any of these, you'll see later, there's many applications running in the system. If one of them fails, it's going to switch over to the secondary. So it's possible that most of the applications run here, but one of them run here. Yeah, it's possible. Okay. Like I said, if the primary is completely unavailable, secondary will take over. However, it will not switch over if the LAN 1 interface. So we don't have any mechanism right now to detect if this interface is not available, but available here. All right? So there's no way for me to verify if this is available because the IP is unassigned. Okay? So maybe when we finish the SIP HA.
Remind me again. So if I lose a link on one of my interfaces, it won't switch over?
It won't switch over.
We need to create either channel and go from there.
Yeah, I gotta figure that out.
Okay? The thing is, here I showed only one, but there may be like 4 interfaces here.
Yeah.
Okay? If one of them goes down, it's not going to start using this one. Okay? The main module here is the TB router.
Right.
Okay? TB router is running here. All the interfaces come in here, and I cannot right now have some of the interfaces here, some of the interfaces here. Okay? So I know that's why I talk about it, because these are type of things we've been asked, right? But right now,
So you can run your applications on multiples
Yeah, exactly. Or all of them need to be on the same one. Right. Right.
Is there any I know you guys are running CentOS under the hood.
Yes.
Is there any way that that can be scripted on our own? You know, say I wanted to go to script to ping the naps, and if the primary can't ping the naps, that it forces the failover?
Actually, you can. Actually, you can. So the SBC application is TB router. It's just an application, right? So you can go underneath, since we always give root access to the systems. You can go in and just kill the TB router, all right? So if you kill it here, then it's going to switch over to this one. All right? So you can force it to do that, but there's no automatic mechanism in our system to do that.
How is licensing for redundancy? Do you need like 2 licenses?
You need 2 product keys, one here, one here. You need to have the primary SBC as a Pro SBC, and the secondary, you just need to ask us, right? When you go on the store, for example, you can say, I want a Pro SBC and a 1+1. The 1+1 is free, right? So you just need to say you want it. If you order it from the sales guy, you just say, I want the 1+1. But you have 2 product key and 2 different licenses. Yeah. Okay. I see you have a question. Ask your question.
I was just thinking about the IPs.
Yeah.
So it shows the IPs unassigned. Does that mean it
Yeah.
automatically adopts?
Yeah, it's floating like the.
It's a floating, yeah. So it's you cannot ping it, you cannot until it has fallen over. And right now, the only way to test if your redundancy is really working is to do it, right? So you shut down this one and say, okay, everything is back up on the secondary, right?
So if I heard you right, by killing the TV router service on the primary, that'll force it it'll force the secondary to
Yeah.
come online?
The only thing I have to verify is, because it takes a few seconds for the secondary to say, whoa, this one is gone, right? And then wait just a little bit longer to say, I'm sure it's gone, then I'm going to start. So if it restarts too quick, maybe it's still going to be here. So we just need to verify, maybe there's another way to just make sure it shuts down long enough so that this one takes over. But for sure, you can do that. And that's the way we test it as well, right? I go here, I do a command, stop the service, right? TB toolpack stop, and everything goes down, and then this one takes over, right? So you can do the same by killing all the applications, right? So yeah, there's a way to do that.
So this is not an HA scenario, this is a redundancy scenario.
It's redundant, yes, redundant. But in our documentation, you may see high availability, redundancy. It's all mixed up sometimes.
That's confusing.
Both got the same IP or using a floating IP?
Here and here, you mean?
Yeah.
This one is unassigned, like at the start. So it's a floating IP. So if this one goes down or you shut down TB router, then this one will be assigned these IPs and rediscovered in the network and start the traffic again.
When you check the system, you see the interface is down. Quand le secondaire remonte, il passe up.
This one is down?
It's down, yes.
Okay, so if because you have access to the secondary device here, so you can check the interface, it's down. Okay, it's down, and then when this one goes down, then this one comes back up with the IPs.
Does it send out a gratuitous ARP to make sure that the rest of the network knows that?
I don't know. I don't know. But could we? Yeah, the problem with that is you need to monitor on the other end to see if it's being received. So
I'm just concerned about an upstream switch having a poison route cache or ARP cache at that point.
yeah. The only thing I can say is that it works, but I don't know if it sends that. But we could verify. Gratuitous, ARP gratuit. Can't say it.
We had the same concern testing the mobile one.
You had the concern?
We had that same concern.
Okay.
Now we'd have our poisoning because we're switching interfaces.
Did you test it or?
Well, we tested it forcibly by powering down the VM the primary was running on, and we didn't have any problems. So we haven't done any load testing yet.
Okay. So it works, but maybe not in all situations. Or it's still some things to do. Who did redundancy? I know you guys did redundancy. Redundancy? No. It's not so difficult to set up, right?
No.
Yeah. It's pretty easy to set up, and it works most of the case. There's still things to tune, and we're always stuff. But as you may understand, it adds a lot of work for the engineering team to test all the scenarios of failure. It's incredible how much more work this gives to the team, and we have tons of regression tests that are being passed just to satisfy all the needs. So every time we want to add one more little function, it's a lot of work behind. Even if the function itself could be very simple, it's a lot of work. So we're careful. We take baby steps and make it work, try to make it work, and make sure it works for every other release that are being sent after. Okay.
I got a question for you.
Sure.
On the other side of the SBC, which is going, let's say, to the class 5 switch.
Yep.
That means if I shut my class 5 switch, it's not going to know that that link is down.
It's not gonna know this link is down.
Oh, shit.
So the other, let's say you have,
Scenario?
let's say you have two soft switch with different IPs. Is that what you?
Yeah.
So I think
But I can program it that if one doesn't respond, to send to the other.
exactly. So this would be managed in the routing and not at the redundant level like this.
Okay.
Okay. Now, what we don't protect here is the local interface here.
Right.
Anything above it can be configured to work. Okay.
If the NIC fails,
If the NIC fails, there's no protection right now for that. Yeah. So you need to, first you would shut down your primary SBC so that everything goes on the secondary, and then you would need to fix the primary one.
Yeah, so your monitoring will catch that hopefully.
Yeah, well, the monitoring will send a SNMP trap for a network interface that is down. Down, does it mean it's completely down, or it's for us it's just we can't talk to it anymore or something like that, right?
Wow.
If you have the SBC talking to another SBC to SBC traffic, will it drop the call on the first SBC as well, or will the first SBC continue to retry back to this redundancy? If you're running
Another one here, you mean?
Yes, another
okay, and there's a call that is being sent here.
Yes.
Okay, and
when that fails over, will the first SBC retry the call, or is that call killed all the way through the first SBC?
right now, the way we have it is here, the SIP stack that we run a SIP stack here, a SIP stack here. This other SIP stack is unaware of any calls. So when you switch over, it's not going to know any call, all the calls will be dropped.
Yes, I understand that stack.
Okay.
Right, yep.
Okay? The SIP HA we're doing, this SIP stack will be aware of the calls that are there. Then when we switch over, he knows all these calls, and it's going to take a few seconds for the IP here to come back up, but the calls will continue. RTP traffic will be rerouted here. Everything. Right now, the calls are dropped.
It's in development.
In development, yeah, for Q2 next year approximately. Yeah. Did that answer your question?
No,
Not exactly.
but,
Okay.
If I'm running it, I'll put it in the scenario. If I'm running the SBC at a call center,
Yep.
install at a call center.
SBC here.
We've got a bunch of nail-ups hooked up to that. Basically, their conference is established to the SBC.
Right.
So that then would continue on to the next SBC as three-way communication to the SBC.
Three-way communication. Okay.
Trying to say like the outbound dials over here, let's say, so there's a two legs here back to like a third leg that would be another SBC. So I'm calling it a three-way because
Okay.
it would be combined.
Okay.
So if the first SBC has that call still established, what I'm saying is, will that continue to reestablish the call to this SBC?
The actual call will be dropped, but the
Yeah,
new
the actual
call.
But I'm saying that that conference that's still taking place, will
That
be
conference.
reestablished over here as soon as that comes back up? Will
I-
that
I-
first SBC be continually requesting that to come through?
I would say it's not gonna try to reestablish the call. Pretty sure it won't try.
It'll say the call died along the way, so
Yeah.
it'll kill the whole thing.
Well, what happens here, I'm not sure, but for sure it will say, whoops, it's. Yeah, it may be even just a bit more complicated than that, because it may not know that it's gone, right? So it can, yeah.
I know it's a few seconds, but I'm not sure if it will, if the first one will kill that, or it'll continue to try and just put lag on the call, and then basically reestablish it, or.
I think that it will not know that it's gone and not try again either.
Okay.
Okay, so your call will just,
The call just
yeah, become, yeah, I think that's what will happen.
Okay.
That's one of the reasons we want to do this page.
I'm definitely proponent of it.
Yeah. But like I say, this is an incredible amount of work. So we go step by step. We'll get it.
Running an HA in front of this, like a secondary, some sort of, third-party HA in front.
Third-party HA? You mean like a rerouting engine or something like that, or? I don't know. I think not, but I can't say for sure. Have a bit more details on that, maybe probably tomorrow. So we'll have another discussion. It's possible to do media bypass. I think it's okay. So I think it's maybe useful mostly in the cloud environments where your RTP traffic, they charge you for your RTP traffic, right? And it can get very expensive quickly, right? So that's one way to do that. However, if you have your own network, your control environments. It's so much better to have the RTP inside the system, control what is coming in, hide the IPs, block it, the type of attack. So there's a lot of things we can't protect if we don't control the media path into the system. Okay, but it's possible to do that. Just one option here, very simple. Right. So then the IPs and port from the remote RTP will be forwarded directly. Of course, we cannot do transcoding, we cannot protect, but in some scenarios it could be interesting. Right.
So the key to that, my understanding, is not just in the SBC, but
Yeah.
also in the NAPs.
Mm-hmm.
Right. So you have to basically allow all UDP ports.
Yeah.
You can't control the UDP ports being used.
No.
For the media, right?
Here we'll have to pass what is being sent from one way or the other. We don't use ICE or these kinds of things either. So yeah. So I think it may not work in all scenarios.
That's what I'm curious about. That's why we haven't cut over yet, because we're still trying to figure that out. Because we're using the Amazon.
Yes, Amazon.
Right. So which is fine, but
How many channels are you using in Amazon? How many sessions?
500.
500 sessions, and you plan to go up to 500. Did you calculate the cost of 500 sessions on Amazon for a month, let's say?
I have no idea.
You don't want to. You don't want to calculate. Okay. You know it's going to be too much, right?
It's going to be too much.
Okay. So you need to do RTP bypass.
Right.
Okay.
What we have to do is figure out how to do it with all the NAPs based upon their scenarios. So if one NAP has a static IP, if they have dynamic IPs, if they have NATs in place, multiple NATs.
So I don't have a lot of things in this presentation for media bypass, so maybe we need to talk outside of the scope of this. So let's see. And I actually don't have a lot of experience with this, so we'll need the team to work with us.
Sardar's been helping me.
Good. Sardar, yeah, he's probably the best in these types of scenarios, right? And these are the options I was telling you about. There's 5 options for choosing which type of codecs are being negotiated from one side to the other. It's only a few options, but it can be complicated, right? So we'll go through that later. So these are the platforms we support now. The bare metal, of course. We've tested a few universal CPE devices. One from Telco Systems. They're using LANer box, but they're using other types of hardware. And I tested the Quotam box. What's the other one? It's the ones from Marketel, Nicole. Do you remember the name of the device? Cirrus, CentOS? Sienna, thank you. Sienna. So we tested Sienna box. So the universal CPE, well, sometimes they run their own version, maybe OpenStack or KVM, right? Something like that. And then they implement firewalls, SD-WAN, and SBCs, right? So we tested some of them like this. And then VMware, I think this is still like 50% of our customers are using VMware. But KVM follows closely. AWS Azure, well, AWS, we've had it already for a long time, but there's not that many customers that went on AWS, probably because of cost issues on the RTP side mainly. Azure, we did that for one specific customer, and we have like 2 or 3 others that started using that. So it's the latest one in our list. And then we get requests for DigitalOcean and so many others. And we sort of say, well, okay, we could do it, but every time we do that, well, like for example, AWS Azure, you need to, one of the problems we have is the TB router is very low level, right? So you need to dig into the cloud platform and try to get the low level hardware. It's very difficult in those cloud platforms. We managed to do it on both of them. Azure, we still have some small issues we need to complete. AWS is working very well, but it is a lot of work to do that, right? So every time we add a new platform here, you have to spend a lot of development effort and regression tests. Every time we do a new version, we start up a AWS and Azure instance, we run all the tests, and when we shut it down, so we can do that. It's all integrated. Some of the performance criteria, right? So I think the 2 main things are the number of sessions you can do on one system and the call rate you want to get through the system. Right? Let's say, as a general approach, bare metal is the best one. Of course, you need to have the physical hardware, it needs to be racked, you need to have your central office, stuff like that. If you go in a virtual, you lose probably 20% of the performance overall. It could be a bit less than that, but of course, much more flexibility. Right? So all my systems here I use are on a virtual system, and for my tests, it's fine. When you deploy that, you need to make sure everything is settled correctly. Right? And then the cloud, well, it has been difficult to get more than 5,000 sessions, I mean with RTP, right? And do we really want to go there? That's the other reason why we didn't push so much there. However, if we do only with no anchoring, then we can do more sessions, right? Then it's just CPU bound. There's no more network interface bound, so we can do much more. Then you have the CPU specification. So there's two things that will affect the performance of the system: the number of cores you have and the core speed of each of those CPUs. So there's a minimum number of cores required to run really well. Right? So when you start a virtual machine instance, they will give you how many CPUs you want to assign to this. This will affect the performance of the system. Core speed will affect mainly just the call rate. Okay? The call rate, because some of these applications can only run on one core, right? So they will, use up this core speed as much as possible.
Luc, is the software CPU intensive or memory intensive?
CPU intensive. The memory is number of sessions, bound to the number of sessions. Okay. Right? So if you have 20,000 sessions, you need that much memory. Okay. So it's very, very specific. Okay. When you configure the system initially, you saw that maybe dedicate core to interfaces, right, in the initial configuration. So if you use non-dedicated cores, it's good for 500 sessions or less. Okay? Or if you have interfaces that are not or less than 1 gigabit per second. All right? So you can do that, and it's still fine. Maybe the SBC will complain sometimes. Oh, I missed a beat, right? Because it needs to process packets quickly, but it can recover usually very fast after. Okay? So this is mainly getting your CPU cycle in the system. Okay? So then you can have reserved CPU. So then we allocate a CPU specifically for processing of the packets received. Right? So mostly, when you choose reserved CPU, let's say you have two interfaces, 1 gigabit per second interface, and you choose dedicated cores, it's not going to reserve one core for each one of them. Okay? The system will check after and say, these are 1 gigabit per second, I can handle up to 5. Right? So you can put 5 assigned to the same core, and it's going to be, I'm fine, I can receive all those packets and go line rate. The important thing is line rate, right, for the denial of service attacks, right? And if you want to go over than 5 interfaces, then the system will automatically reserve 2 cores for each of the 10 gigabit per second interface that are available. All right? So you see here, if you have like 2 10 gigabit per second interface, it will eat up 4 cores of the system. Okay? If you choose dedicated, but at 10 gigabit per second, you need to use dedicated. Otherwise, it's always going to run and not have enough interrupt cycles to gather all the packets. Right? Now, this is defined in a specific file called nic.json. I don't know if you saw it or played with it a little bit. It's very critical, right? Because it defines how your network interfaces are bounded to your cores, how many threads you will use, how many buffers and stuff like that. Okay, so it defines low-level stuff, but you can really tune it for your system. Okay? The system will, once you choose your initial configuration, it will do a nic.json the way it thinks it is the best, but it may not always be the best. Okay? So we can go then after and feed that. Most of the time, you will see in the web interface, you will see either something like suboptimal configuration, or it can be there's another element that says SBC. We'll see that SBC not processing enough, right? So we can see that, and then we can go here and modify it so that it's more efficient. I'll show you that later. Okay. So this is just a bit more of a graphic view. The other thing that we have to be careful is these hyperthreads, right? When you get a CPU, it will tell you how many cores you have, how many real cores, and how many hyperthreads you have with that. The trick with hyperthread is that when you have TB router running, you can't use the hyperthread. You can't be interrupted in that CPU. All right? So TB router will automatically take both of these cores. One a real core, one is the hyperthread core. But when you go on any platform, VMware, KVM, stuff like that, it will say a vCPU. Right? This is one vCPU, this is one vCPU. Right? So it's actually going to take two parts of this CPU for TB router. And then if you have up to 1 gigabit per second, well, they all can be attached to the same real core, but it's going to use up the hyperthread as well. Each of these 1 gigabit can do about 5,000 sessions of G711. Okay? If you use G729, G723, G728, you can do more sessions. Each of the interfaces can do more than 5,000 sessions. Okay? It's really a bandwidth issue here. Okay? So, other cores, well, they see it says reserve. It's not really reserve. It's really other cores are used for these applications. Okay? And I really separated it in four elements. One is gateway, engine, TBSIP, and other applications. Okay? Why did I separate it this way? Is that these three are the ones that are processing calls. Okay? If you want to have maximum call rate on the system, each one of these should be on a different CPU core or hyperthread. It's fine to have these in a hyperthread. And then you will have maximum performance. And that's why here, this gateway can run only on one of those cores, because it's just one thread that is running here. And it is, to have maximum capacity, it runs on the same. I forgot what to say. Other applications, well, that's the web interface, SNMP, call trace, CDR, all these things. These can run on one or other CPU. It doesn't affect the call rate of the system. Okay? Call rate is really affected by these three. Yes, I remember what I wanted to say. CPU core here is the speed of that CPU core that will give you more performance. If you have a 2 gigahertz or if you have a 4 gigahertz, well, you get twice as much call rate. Very linear. Okay? Yeah. So we have a customer in Indonesia, right? And he has a 12,000 session SBC, and it's one of application like you have, which is blasting out calls like crazy. He was doing 500 calls per second.
Oh, more than that?
No, but before.
Yeah.
More than that?
No,
around 500. Okay, because he was using, I think it was a 24 core, 2.2 gigahertz system. All right, so you have a lot of cores, but most of them are not used. Right? You're just running on the same 6, 8, 10 cores that are doing all the work. The others are doing nothing. So we analyzed their system and then we said, okay, well, probably just an 8 core. Right, or a 4 plus 4 core, or 8 plus 8, right? But instead of 2 gigahertz, go to 4 gigahertz, right? You have 4 point something gigahertz now. He doubled his performance. He's what, at 1,000 calls per second now? Yeah, so 1,000 calls per second, right? So when you reach those levels, you need to be a bit, it's important to have the right hardware. They are bare metal, of course, to reach maximum performance. If you try to do that on VMware, you lose some of the performance, right? And it's difficult to run other stuff anyway in those SBCs. And what we have seen right now is Gateway uses more CPU than these two other applications. That's in general what we see. So for us, if we would want to improve the performance, we would need to be able to have this run on multiple cores. Future project.
Yeah, right now you can only dedicate it to one core.
Yeah, yeah.
So if I got a 32-core machine, I'm not.
It's not gonna help you.
More than what, 6 cores?
Yeah, so did I have, no, I didn't have it. So depending on many interfaces, that's one of the things, because maybe you will use more cores because of TB router. But let's say you have it something like this, then 4 plus 4, yeah, you're pretty good. Maybe 2 more cores to be sure that these other applications these one can run on multiple cores. So, but all right. So if you use a 10 gigabit NIC, then you need two interfaces, 2 cores, 2 real cores that takes up 4. Right.
The affectation of CPU, enfin, je parle en français. L'affectation des CPU, c'est donc dans le fichier NIC pour les TV routers.
C'est ça.
Et après pour le reste, c'est automatique ou tu peux...
Automatique.
C'est automatique.
Oui. Right, so these ones will be assigned initially when you configure the system, or you can modify it with the NIC.json later. These ones, they will be optimized. So automatically we'll try to use the best scenario possible to get the maximum call rate. You can verify that in the status. Do you want to just note it down? I think I have a slide. Yeah, I have a slide on that. No, we're good. I will show you where to check that, and then you can see how close you are to the maximum of this particular platform. And maybe we can tune this particular platform to get more call rate, or maybe we'll say, well, no, we've reached the maximum of this platform. We need to get to a new system. So some of our customers, they need a lot of functionalities. Other customers, they need a lot of performance, but less functionalities, right?
So in a VMware environment, this would hold true as well. We wouldn't need a 16 cores in a VMware. Okay.
Well, it's a question, right? Do you need 25 calls per second? Well, 25 calls per second, all of them can run on the same CPU here, right? All of these applications will run there. The other CPUs can be used for something else. It's fine, right?
And do you also have like recommendations for VMware setup? Like you should go into low latency or high latency settings?
Yeah, in the installation page, so it's because of TB router, mainly because of this application, not the others, but these ones, we need low latency. What are the other options that we have in the VMware? It's I reservation, CPU reservation, and stuff like that. It's defined. You don't have to do it, but you will see usually when it's not done, you see in the web portal, the SBC is complaining, right? So I'm losing some cycles there. So most of the time it's not affecting, but if you're getting close to the limit, yeah, and the other thing is, well, the tricky part is the attacks. Right? We want to be able to protect against each type of attack. So if you want to do that, you need to be line rate, be able to capture all the packets and say this one's good, this one's bad, this one's good, this one's bad, right? And analyze all of them without affecting the rest of the system. So that's why these are dedicated, not for regular usage, but because you can see here the CPU usage. I mean, okay, let me start again. The CPU usage, you will see of this TB router will be 100%. Right? Because it's an infinite loop that will just wait for packets to come in. So if you look at the regular top from CentOS, it's 100%. Yes, okay, it's 100% because it takes full control of that core. Now, if you look in our stuff, in the web portal or in our tools, you can see the real CPU usage of the TB router. All right, so 3%, 6%, 15%. All right, so you can see the real CPU usage. And I forgot where I was going with this.
Quand on a, je peux le dire en anglais, quand on a un problème de scheduling.
Scheduling problem, exactly. Scheduling problem, okay, scheduling problem, that's when TB router cannot get the next packet quickly enough. Does it matter? Most of the time it doesn't matter, right? Because the next loop around is going to take all the packets that are remaining in the queue. But it's when there's a queue of packets that are received, and then we read from those queue in one cycle, and then the cycle finishes and we don't have time to empty up the queue. Okay? The best way is to empty up the queue every time. On vide la queue à chaque fois.
Et le scheduling est sur le TB router, c'est ça? Le scheduling, quand on voit le scheduling SBC?
Yes.
C'est le TB router?
Oui. It's done here. When we see SBC scheduling, it's TB router. Okay? So when we get an attack, you get flooded with packets, right? So you need to be able to quickly get them out of the way so that your real RTP packets, your real SIP packets are still coming in normally. Okay? Okay, it's good. Continue. So bare metal installation, the ones who have done this, so it's just an ISO image which includes everything, the CentOS, it includes all our software, the web interface and these things. The ISO image here that we put that you can get from the FreeSBC site or ProSBC site, it has not necessarily the latest security patches from CentOS. So you may need to do a YUM update, an update of the kernel after the installation. So every time we do a new image, no, not right. Sometimes when we do a new image, we incorporate all the new fixes and are there, but sometimes we don't. So you have to maybe do just one more step here when you install a new system is to update the kernel as well. We get we do updates every about 6 weeks or closer if it's more priority security patches for the kernel. So we can't always put that into new images, right? But it's available on our repository and you can update the CentOS. There is also a offline procedure for uploading it if your SBC doesn't have internet access from the management. Okay. So then this is what we talked about, right? So you have specifications of the CPU which will affect the performance of the system. And then you have your, well, we call it LAN 1 interfaces. LAN 1 interfaces are the ones that are SBC protected. Okay, so they go through the TB router. Other ports don't go through the TB router, like the management port. It's a separate interface. It goes directly to the CentOS system. Oh, it's here, the management port, directly in the CentOS system. Here we just put LAN 1. I think we had no other best name to do that, but it can be anything, right? Any type of interface you want to have protected by the SBC. You can name it as you want. Okay.
How does that change in AWS? You only actually have one interface.
I will show you in a second. This is perfect. This is perfect. When you do that, it's perfect. That means I did it correctly, right? Well, this is the before slide. The cloud is the next one, right? So here the difference is you have a hypervisor in a VMware system. The hypervisor can be Hyper-V, can be for Azure, it's Hyper-V, for AWS, no, not AWS, but VMware, it's the name, what's it called?
ESX.
Thank you. ESX, ESXi, okay, so the hypervisor is here. Then you have assigned, they call it vCPUs. vCPUs are either real cores or hyperthreads, or a mix of both, right? So when your stuff can run on different spaces inside those CPUs, unless you reserve the space. That's why we asked to reserve the space, because our TB router here should have reserved space so that it runs always in the same core and always without being interrupted as much as possible. The virtual image, well, it's loaded somewhere into the hypervisor group, right? It may not be exactly like this, but you have your image that's stored somewhere, and then you can start your instance of SBC by, choosing the virtual image and the parameters for your virtual image. Okay. The trick here is that your interfaces need to go through the hypervisor here to reach the LAN 1. Right? So these interfaces need to be pretty efficient. So there's different ways to get to the LAN 1 interfaces. Let's say the default one, E1000, is fine for smaller number of sessions, well, smaller, I say, less than 5,000 sessions. Okay, it's fine with E1000. VMX Net 3 is more performant. You can do, I think it's maybe 8,000 sessions or something like that, but still it's a virtualized type of interface. MacVTAP is more for KVM and OpenStack, virtualized. And then you have SRIOV, and I forgot the acronym name. But, well, let me start with pass-through. Right? So pass-through here, you attach directly the SBC to the network interface. So you bypass the hypervisor completely. So you attach directly, and so you have maximum performance of that. However, it has some limitation because, well, first you can't move that machine to another system because it's attached to a physical device. And other systems running, other applications running on the same VM machine cannot access that interface, right? Because it's blocked for this one. SRIOV, almost the same, except that you can share. Right? So it would be possible to share one of these interfaces to two different applications with SRIOV, but you still tap in directly to the Ethernet, buffers and queues. Okay.
What's the minimum number of network interfaces you need? 3 or can you go to
Here?
No. Yeah, how many you need?
Okay, the minimum, let's say today the minimum is 2. So you need one management and one LAN 1 type interface. That's the minimum. Most of the installation I see are 3, like this. Okay? So one management, 2 interfaces, one facing the external network, one facing the internal network, just to make sure it's separated. Less chance of conflict. We have done, but I think I don't have this available version. We have done one that have only one interface here. But let's say 2 is really the optimal one. Okay? Yes?
The base OS for SBC, it's CentOS or Linux?
It's CentOS 7.
Okay.
That's what we use.
I was asking because in case we have to install the VMware tool to monitor so we can...
If you take the virtual, the VM image,
Yeah, the VM.
it has the VMware tools. I'm almost certain it has the VMware tools. And the same thing for KVM, it has the libvirt.
Sometimes the VMX Net 3 doesn't work without the tool.
There you go. So yeah, so we can support that. Yeah. And then the cloud one. So here you see, well, let's start with the beginning, right? You have a region, right? A region is Canada, I think it's Toronto for AWS, and then you have US, it's Montreal? It's Montreal, okay, thank you. The other one is maybe Oregon, US, and then you have London, EU, right? So it's a region. So for them, it's a central office. That's what it is, right? And in that central office, you have some cloud storage somewhere in the region. When you allocate your instance here, you can choose in which subnet inside that region you can start it. And the interesting thing with this is that you can start other applications in the same subnet. Okay? When you're in the same subnet, you're not paying for this fee of public IP transmitting data. If you transmit data between devices on the same subnet, then it's not chargeable. right? So it's important when you want to do a full cloud system. You have other subnets in the same region. You have many regions around the world. The default is to have just one interface, which will serve both as management and SBC traffic, but you can add more. You can add more. So you just have to go in this, the configuration of the instance, and you say, oh, I want one more network interface, and this is added to the system like this. Okay. Was that, did that answer your question or not? Not exactly, eh? Almost.
Almost. Because we only have the one, there's only one IP.
Yeah, so the default is this one. All right, so I have just one, which is used for management, used for SBC, which is used for everything. But you can add more if you want. Yeah. So it's documented on our wiki, but you have to maybe find where it is. Once you find it, then you say, okay, you have to do this, tick, 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 and oh, you have one more IP. Yeah.
Okay.
You assign it to the system.
So then within the SBC, I can assign the IP as management or public.
Public, you mean one interface? Yes, exactly.
Yeah.
Yeah.
But with only the one interface, the question is for security purposes, because you said before the SBC is not part of the management.
Yeah, exactly, and I would need to verify that, but I think since it goes all through the same interface, it's protected. This one is protected automatically, yeah.
Okay.
So just good thing you made me think of something is that if you have something like this, right, and you say, well, this one is, yeah, sure, it's not protected, so you can actually configure a management part on a protected interface instead. Right, so you can add one more IP interface, say this is on this interface, and then you can disconnect this one or keep it in a protected environment. So this you could then reach from outside to the system. The only trick here is that it goes through TB router. It goes through that TB router interface. And when you use 1+1, well, you could have the same IP on both systems. All right. Or, well, you can choose. You can choose how you configure it. You can choose to have the same IP or a different IP. Yeah. But it's all feasible. The only package I don't have right now is one that has only one interface on a bare metal, for example. You cannot just have one interface. You still need to configure the management, even if you don't use it. Okay, so first part is done, if you don't have any more questions. And we take a break. I'm just 10 minutes late, it's pretty good.
Congratulations, you completed your first module. You can now move on to the next module by clicking in the box over here.